Welcome back to the lab. In this video, we're going to be talking about TypeScript. I'm really focusing on branded types. What are they and when you should use them? So I recently came across TypeScript's branded types at work and thought they were a useful tool for getting more value out of TypeScript's type system. So here we'll dive into what TypeScript branded types are, how to use them, and when it might be useful for you. TypeScript types. So first let's talk about TypeScript types and why branded types are even useful. TypeScript uses structural typing, which basically means if the structure of one type matches the expected structure of the type definition, then it's accepted. This works fine in many cases and is the default for many languages like Go and Python. The issue occurs when you want to tell two different types apart that look the same. Now, this is relatively common with primitive types like string fields, although this can also happen with more complex types. And so we'll go through a few examples here to kind of show this. And so I have the examples in the post, but I've brought them out into this TypeScript playground so that we can get some syntax highlighting and kind of see how this would work in production. And so the idea here is that we have two different IDs, and the IDs are just using strings under the hood. Let's imagine they're like untyped goods or something. And we have a user ID and an order ID. And then I have a function called getUserInfo that takes in a user ID. And then we're going to basically create both a user ID and an order ID here. And then we're going to show that actually, due to structural typing, we can pass the user ID or the order ID into this function and it thinks it's fine. And the reason it thinks it's fine is because structurally it is okay. Like the function won't choke on this. They're both strings under the hood, but semantically they mean different things. These are not the same types semantically from what we mean, but the compiler or linter doesn't see a problem with it because it's like they're both strings, who cares? And so this works with primitives, but it also works with objects that have things that are named the same thing and have the same value or the same type. Okay, so on to TypeScript branded types. So branded types provide a bit of extra info on the type, which helps TypeScript understand that these types are actually unique. They should not be thought of as the same even though they're both strings. This extra info is stripped at compile time, so there is no runtime hit to performance here. And we can add brands to the type by adding a read-only __ brand field, and then we use a unique symbol so that the compiler knows that these are unique. If you put the same value into types that are structurally the same, it will still think they're the same, so that's why we use unique symbol here. So example here, and we'll also look in our playground. And so here we're basically doing the exact same thing. We have the user ID, and we're just saying it's user ID, which again is basically just a string. But then we're adding this extra bit of info on here, which is a read-only field. It's this -- brand, and we're giving it a unique symbol. So we're basically saying, yes, this is a string, but we're branding it, putting extra information on it so that you can tell that this is actually going to be different from anything else that looks like this. And we do the same thing to order ID here. And then we change our function to only take in this branded ID. Then we create our two values here, and then we can see that it works fine for the branded user ID, but it's going to fail on these other cases. So it doesn't work for the branded order ID, and it also doesn't work for just the string values that we created above, even though they're really the same exact types. But because we've added this brand on it, the compiler, transpiler is like, wait, this isn't the same. I can't let it through. And so this kind of thing is very commonly useful for IDs, especially if all the IDs look exactly the same. They're GUIDs. How do you know if this is, a user ID or an order ID or a post ID or whatever kind of ID? This is a way that you can add some protection in there. All right, so when should you use branded types? So I think branded types are useful whenever you want to differentiate one type from another. This plays particularly well with the parse don't validate paradigm, where you try to leverage the type system to prove that a type is valid. And so instead of every function that operates on a user ID having to take in the user ID and then it goes and checks if a user even exists with this ID to kind of figure out is this a real ID or not, if we can instead have the type system always type these user IDs as user IDs, then at least we know that this is a valid looking user ID. We don't necessarily know if the user exists in the database or anything like that, but we can avoid any kind of validation checks on is this actually a user ID that you're trying to use. For just one case, this doesn't maybe remove much validation, doesn't really make things super clear, but if you do this throughout a program, it removes a lot of cruft in the form of removing the need to have validations everywhere. And so a simple example of trying to do this would be to do something like try parse valid user ID, where you pass in a user ID, which is just a string, and then you could do your validations in one place. Obviously, this is a useless validation, but you could have your real validations is this really a GUID? Is this well-formed? You might even do, does the user exist? And then what you can do is you can return this branded type, and now anyone else who uses or receives this user ID branded now knows that this is a valid user ID. I don't have to do these checks again because they've already been done above. And this is much better than doing like, a validate or throw kind of scenario, because if you do a validate or throw in your function, nobody else can use that information. But if at the top, of your control flow, you do something like this, then everyone who you call who uses this doesn't have to do the validation, because we can trust that someone already did this. And then to use it, you just pass in the my user ID we created at the beginning into here, and if it's not equal to null, then you can actually use it to do whatever you want. All right, other ways to brand types. So the branding provided here is a bit tedious, and so I found a few different ways to make this easier, but I think this really is probably the most universally useful version of this. And basically what we're doing here is we're creating a specific type, brand KT, where K is the actual type that we want to use, the underlying structure, if you will. And then the brand is T, which is a string. And then what you can do is create yours, and then with brand duration valid duration, we're able to create a branded version of a type we already have. And you don't have to pass it in. You could just create your type in line if you wanted to. And then the key here is that instead of using a unique symbol, we are using like a string here to create our unique symbol, which it could clash, but in general, it probably won't, because usually you won't have clashing names. But if you are, you might have to think about this a little bit and add some extra information on here. I guess you could even use a GUID here, but I think this is pretty clear. It's pretty easy to understand how it works, and it works in 95% of cases. So this is the way that I would probably recommend doing this in your own code base. And here's just another example of when you might use it. We have a duration, start, end, and we're showing that even if this is an invalid duration, you can still use it to get the duration in milliseconds, but perhaps you want to do a little bit better on that. So we've created a brand for duration that's really just called valid duration. And usually when you're branding something, you don't include brand on it for the most part. Usually you're going to want to say why is this a unique type? So here it's unique from duration because it's a valid duration. We've already validated it. And then so we're going to have our helper function here, which will try to get a valid duration from a duration passed in. So here we're just going to say, if the duration end is less than start, then this is invalid. You did something wrong, so return null. Otherwise, we'll cast it to valid duration. And then we'll create a new function to get this duration here that only takes invalid duration. And now we get a little bit more protection here. We can't do this on my duration because it hasn't been validated yet. And now you can only call it with a validated thing, which again helps you kind of protect your program. Validate once, and you can protect all code paths below you on this type. And I think this is a really useful way to do this, I think. And I see it more as a functional version of what a lot of object validations would in OO, where you try to create this new type, and when you try to create it, it does all these checks. I personally prefer this more functional approach because you have a bit more control on what happens if it's failing to create, instead of a constructor where you're probably going to throw or something. You can say just give me a null, or give me a result type with information on why it failed, and then I can do something with it. And so I think this is a lighter weight, more universally useful version of that, and really branded types are what allow this to happen in TypeScript. Next. So yeah, TypeScript remains one of my favorite programming languages in 2025, largely due to its ecosystem and type system. Branded types help me leverage the type system just a bit better. And I think types, when done well, are really one of the superpowers of programming languages. And I think we should really push on these to make sure that, all the languages kind of catch up and add these things, because I think they really are how code bases scale. So if you like this post, you might also like why type-safe programming languages are better than dynamic and lead to faster, safer software at scale. Might also be interested in my 2025 programming language tier list. And finally, types versus no types, how types allow code to scale across developers, organizations, and lines of code. So that's it for this video. Thanks for watching, and I'll see you in the next one.